Okay, let's give you guys some more practice. So find the limit of this as x tends to infinity. So as x tends to infinity, it's heading towards a limit. Find that limit. So press pause and have a go. Okay, so to do this, let's just say this whole limit here is y. So let's just say the whole limit here is y. So now log equally to both sides. So when you log this, the x will come down, which will give you this. You've got your natural log here, and whatever here, and you've got your whatever here. So now let's test it. So here you've got one block multiplying another block. As x tends to infinity, this is going to head towards infinity. As x tends to infinity, this thing here, as x tends to infinity, this 2 here is going to be irrelevant. So this bubble here, the numerator, will just be this bit here, will just be x. And then as x tends to infinity, this thing here, this negative 1, will be irrelevant. So it really boils down to just x here. So as x tends to infinity, this whole thing here is going to head towards 1. So this whole thing here heads towards 1. So if you look at the natural log here, this here is 1. As x tends to infinity, this whole thing here is heading towards 1, making this this whole thing here will head towards 0. So you've got this thing here, which is infinity. You've got this thing here, which is 0. So here you've got a product. Whenever you have a product, you can always rewrite it as a fraction. So rewrite this whole thing here as a fraction. Rewrite as this. So now let's check it again. So as x tends to infinity, this whole thing here will head towards 1. Then natural log of 1 is this whole thing here is going to head towards 0. So as x tends towards infinity, this whole thing here will head towards 0. And then as x tends towards infinity, this thing here will head towards 0. So here you've got an indeterminate form, so you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this, that will then give you this whole thing here. Differentiate this, that will then give you this thing here. So when you come to differentiate this, just imagine this as being log of a bubble, where the bubble is x plus 2 over x minus 1 in here. But just imagine, when you come to differentiate this, just imagine it as being like this. So when you differentiate this, it will be 1 over the bubble, and then you times the derivative of the bubble itself. So you've got to use the quotient here, the quotient rule here. So this is a quotient rule. 1 over that thing is really the reciprocal of well, think about it. If you differentiate this, it will then take you to here. Differentiate this, that will then take you to here. So now it's just a matter of tidying it up. So tidy this up. This whole thing here will become negative 3. That's this bit here. This will stay the same, and then you've got this thing, and then this thing squared, this thing squared. So well, just tidy up. This thing will then become this, and then tidy up again. So imagine this as being a fraction times the reciprocal of this. So now these two negatives will cancel each other out. Blah blah blah. That will then take you to here, because this will cancel out with this. So that will then take you to here. So now multiply this whole thing out. That will then give you this. So when you come when you get to this stage here, just have a quick glance. As x tends to infinity, this whole thing here, this is going to be irrelevant. This is going to be irrelevant. As x tends to infinity, it is this that's going to dominate whatever is at the bottom here. Well, okay, let's just stick to our normal routine then. So when you get to this stage here, divide everything by x squared. So when you get to this stage here, imagine this as being like one thing divided by x squared. That will then give you this. Let's just imagine this thing as one thing. Divide everything by x squared. So that will then give you this. Divide everything by x squared. Divide everything by x squared. That will then give you this. As x tends to infinity, this is going to head towards 0. This thing here is going to head towards 1. So you've got this thing over 1, which is just this thing here. And then if you look at this thing here, well, the limit here will be 3. Okay, so as x tends to infinity, this whole thing here will head towards 3. So now now we're at this stage here. So e equally to both sides. That will then give you this, and in a way, these two will cancel each other out, giving you y. So y is in fact e to the power of 3. So if you get a graph plot and plot e to the power of 3, it will give you this horizontal line, and it is heading towards that horizontal line. Okay.